Yeah, we can.
This meeting is being recorded.
So basically, what yesterday we have seen is we have just gone through an overview of the Ansible, right? So today we are going to start our first chapter. And of course, yesterday also we have whatever we have discussed is a part of the first chapter only, but we will go again in depth of the concept today. Okay. And one more thing, many times, like when I started Ansible training, right? Many times people have a doubt like what I mean already I mentioned a content in front of you yesterday, the course content. So you'll have a doubt whether it is a standard content or not, right? See, what happens is when it comes to automation DevOps tool, many times you might go with any training, DevOps tool training. There is not a standard content actually. They only train from here and some part of the content and they just wind up the training. This is what exactly I have seen it. Even I have taken some trainings long back. Okay, for the DevOps I used to see. Okay, so this is what happened. So what I am doing here is when it comes to Ansible engine. Okay, so Ansible engine, we are following a standard content of Red Hat. Okay, for example, I'm covering the course content of RH294, right? This is whatever the chapters we have in this book, we are going to cover all these things. Why? Because like in future, like take an example, after you take this training, maybe after 3 months, after 4 months, after 6 months, right? Anyhow, you will have a good hold on the Ansible. Maybe you will be regularly working on it after 8 months or 9 months, after 1 year. Like if you are willing to write any certification for RS294, okay, without any other training, you can just take an exam preparation and you can write the exam, right? This is the goal behind why we are going with the standard content. Okay, then apart from this, we also have another code that is called Devo 447. So when I'm talking about Devo 447, is like advanced automation we call. Okay, so advanced automation, right? So when I'm saying advanced automation, from this, actually, we are going to cover Ansible Tower. Okay, so Ansible Tower. So basically, I will not say that we are going to cover the entire content of Tower from DO447. Okay, this is something like, in many organizations, people are using Ansible Tower, but people who are working on a tower, they don't know how to handle the things. They don't know from where the playbooks are coming. They don't know from where the inventories are defined. They only blindly work on this. They blindly they work on this. You will see a systematic, dashboard on your web browser. Whatever the instructions it comes to you, you will just do next, next, next. You'll complete it. But like when you try to know where this playbook is coming, you never understand this. How the things are happening, you never understand. So that's the reason what we are doing is, let us, we are just covering a 8 to 10 hour session from the tower. Like we will be discussing something features of tower. I'll show you like how do we implement tower, and I'll also tell you about something tower concepts like clusters. Inside the tower we have a concept called clusters, tower clusters, and we have something called inside the tower you have a one, okay, two-tier architecture, three-tier architecture, right? Then apart from the services and the configurations and how to update the license, right? Like this, we are going to cover up to an intermediate level of, in training on the tower, so that, whenever you get some task on the tower, you will never feel that you are totally new to it. You will just try to handle the things, right? So you handling the things by understanding everything. This is very important. You will also know by learning the tower, you will come to know from where the playbooks are being pulled, from where the inventories are pulled, how the dynamic inventories are being maintained, right? All those things you will be clearly understanding, right? So this is a major goal of the training here. So let's do one thing. I'll just try to take you into the content here. So basically, when I'm just talking about the content here, as yesterday we have discussed about the things, we have discussed all these things. Why this is the first chapter exactly. So introduction to Ansible, answer. Okay. So in this is what exactly we have discussed here, automating Linux system, Linux administration with Ansible. So I'm not going again through this. So basically from many years, most of the system administration and the infrastructure management has relied on the manual task performed through the graphic or command line user interface. System administrator offer work from checklist. You know, checklist is nothing but you get some document. You will check, okay, this step is done. Okay, then this step is done. Yes, this is done. Then finally, you will see a proper output, right? So take an example. If you're not following that checklist, you missed some steps within that checklist. So will I be able to get an output? No, we never get an output. But this is what exactly. Otherwise, sometimes, you know, we see that, oh, last month we got some task and today also we got it. We want to like perform the same thing. What you will do? You recall all the steps, what you have done the last month or before a month, and you will try to work on it, right? So this is what exactly it is going to work. Please mute on your side, right? Okay. So this is what exactly it is going to happen, right? So this kind of approach, it is an error prone, right? And it is easy for a system administrator to script the steps performed by step mistakes. Okay. And often there is a limited verification that the steps were performed properly and that they result into an expected outcome. This is what exactly happens. So this is all about to overcome all these problems, to overcome all this, situations. Okay, what we are going to do is we are going to take the help of automation. So automation is going to solve all your manual system administration, infrastructure management problems will be solved here, right? So you can deploy quickly, you can make your environment more productivity. This is all the benefits that you are going to see with the help of Ansible, right? This is all the informations. Okay, so infrastructure as a code, yes, you know, like when your entire infrastructure is being defined as a code and we are going to deploy everything. Okay, so this is all one important things here. So mitigating human errors, already we have discussed how do we mitigate the human errors. And we also discuss what is Ansible. So as you know that Ansible is an open source automation platform. Okay, it's a simple automation language that, you know, can be preferred, you know, perfectly describe the IT infrastructure. Okay, IT or application infrastructure in a playbook, Ansible playbook. So this is very important. And we also discussed that Ansible playbook is written in a user-friendly language or human readable language that is called YAML, right? Yesterday we have seen like how the YAML looked like. So of course, YAML is also very good uh, language, we can say. It is a data digitalization language. And I don't say that it is tough. It is easy only. Like how do we see a Python or Perl coding? In the same way, YAML is also such a big language, right? But what we are going to do is very simple. We are not getting much into the YAML. We will just try to see the basic things that helps you out in just writing the playbooks very confidently, right? So we will be discussing that later, not now, maybe in the second to third chapter between we will be discussing all about the YAML. There's a very simple terminologies the YAML is going to provide you. Like YAML has a terminologies like dictionary, I mean list, dictionary, dictionary of list, list of dictionary. This is a terminology you should understand. So what exactly the list represent, what exactly the dictionary represents. Okay, so what exactly the dictionary of list or list of dictionaries are being represented. All these things are very important to us, right? So we will be discussing and we will try to understand very detailedly about it, right? So this is all about the information here. And Ansible can manage powerful automation tasks and can adapt to many different workflows and environments, right? And as I told you, you can make your environment more productivity, right? So Ansible is simple, you know that it's a human readable automation. This means that the playbooks are automation tools that are also easy for humans to read and comprehend and changes. No special skills are required to write them, right? So you can just open the playbook whenever you want it. You can just go through it and you can understand basically what is the purpose of that particular playbook, right? For what purpose the playbook has been written. They will write you, I mean, the playbook is written in a very descriptive manner. You know, it is not like that they have written, they have run it, not like that. You know, it has been written in a very this, you know, it's very detailed description is given. If I'm using some options, you know, you need to write why this option is used. A note need to be maintained. This is very important. You should write something like, you know, when you write a script, you know what you will do. You will try to start a script like this. First, basically, first you will try to put a shebang, right? So after you put a shebang here, okay, then you will try to put the author name, okay, right? Then you will try to put something like you know, for date and time, date and time you're going to put here, right? Then you will try to put something about for which purpose, the purpose of the script, right? And you will also put for which project, project name, right? Like this, you're going to write all the details, right? So in the same way, when it comes to the Ansible playbook also, right? Yes, this is what exactly you're going to write same inside the Ansible playbook. You're going to put the author name, date and time, the purpose of the script, for which project it is written. If you run this particular script, what exactly it is going to perform, you have to write the script behavior in few lines. All right. So this is what exactly, this is the way how it's going to work. Okay. And the playbook executes the task in order. So playbook execute the task in order in a sense. So what happens, you know, for example, yesterday we have discussed that the playbook will start with 3 dashes and end with 3 dots. And inside this, we try to create a play. Inside the play, we will try to have a modules. I mean, not modules exactly. We have a something called task. Inside the task, we have a module. And inside the modules, we have something called arguments, right? So when I'm talking about a play might have, a playbook might have not only one task, you might have two plays also. You can have two plays also. This is what exactly. And your play might have two tasks also, right? It is not only task one, you can also have a task two, so second task also we can have. You're getting my point. This is what exactly we have. Assume that when you're executing this play, it will execute this task one, and then it will go to the task two. This is the order that is going to go. Then after completing this, it is going to execute this play two. And inside the play two, it will execute the task one and it will execute the task two. This is what exactly it is going to have. So this is going to work in order, right? The simplicity of the playbook design make them usable by every team. So take an example, you have written a playbook for a, you have written a playbook for executing an HTTP. Okay, HTTP is for deploying a web server. Okay, deploy, deploy web server for a like a team, like you're going to do it for a team A. Assume that. Now you want to use a same playbook for team B. Okay. Yes, we are going to do, you can use the same playbook for team B also. But of course, you cannot use the exact playbook. Maybe there might be small changes you need to do it. Like you need to change the host name, or you need to change the location of, I mean, the name of the repository, right? There are small changes you need to make and you can just run it. Okay, so this is exactly the benefit of the playbook. You can also share this playbook with some other team also, some other department also, or you can carry this particular, you can have this particular playbook. And take an example, you're shifting from one project to another project, you're switching from one company to another company, right? Yes, you can use it there also. Okay, you can store all these playbooks, whatever the playbooks you're going to write, for your future usage. You can store all this, playbooks within the GitHub. Okay, within the Git, you can maintain all this. You can create your own GitHub repository. You can upload all the playbooks there. Some playbooks you can give access to the some users, because, I'm having some playbooks, I can make it private. Okay, I can make some playbooks as a public. You're getting my point? Okay, you can use some playbooks as a private, and you can use some public, I mean, as a public. Right? Public means you want to show your skills, you want to show your expertise in writing the playbooks, and you want other people to get benefited with your playbooks. Okay, so what you will do, you will make that playbook through GitHub, you will make it a public, so that anyone who is searching for similar kind of playbook, they come across your playbook and they try to download the code and they try to use it in their project. And if it is a private, you can share within your close circle, because in order to download the playbooks that is kept in the private circle, so you need to give them username and password so that they can download it, right? So these are the benefits that you're going to see. Okay, so this is the things here, right? So there are many people doing this. I'm not saying that if many people are doing it. Okay, they write a very good playbooks, and they keep on update also. Take an example, last year I have written a playbook saying that I want to deploy something called 100 machines in a cloud environment, and for these 100 machines I need to deploy a storage. For these 100 machines I want to deploy a VPC. For these 100 machines I want to create users, and I want to define the images, right? Like this it is there. Okay, so I thought I have written a very good playbook. I have tested, I have implemented, it was working very fine. You know, then what I did is I have shared this particular playbook using a GitHub to the, you know, public people, right? So anyone, for example, you are looking for similar requirement, you might come across, when you search, you might come across my playbook. You might download it and you might make small changes, and you might, fulfill your requirement. This is a benefit here, right? So which allows the people, new to the Ansible, get productivity quickly. Okay, Ansible is powerful, we have discussed already, because Ansible is an automation tool. It is used for everywhere. That is called application deployment. You can use it for configuration management. You can also go for workflow automations, and network automations can be done. For networking, there is a separate course when it comes to Ansible, right? There is a separate code for networking, like people who are working on networking, like CCNA, CCNP, and above the CCNP, like securities, they have a separate course where they can, use the Ansible to automate their entire networks. Entire network. They can sit at one location. They can automate their networks all over the globe. This is a power they have, right? So this is the thing says. So Ansible can be also used for orchestrating the entire application lifecycle management. So this is especially nothing but, when I say that entire application lifecycle management is nothing but um, like a development to testing to production, everything you can do it, right? And Ansible is agentless, already we discussed, because we don't need a specific agent to communicate with your managed host or your client. So we are going to use the well-known service that is called OpenSSH. If it is a Linux and Unix, if it is a Windows, we are going to use something called WinRM. So WinRM stands for Windows Remote Management Tool. It is, this is what exactly, and you know that it is a push mode software. So what it is going to do, pushing out a small program called Ansible modules. So Ansible modules are being pushed from your control node to managed node. And yesterday we have discussed that modules are designed based on the Python. Modules are designed based on the Python. This is very, very important there, right? So and I also told you yesterday, like because the modules or Ansible is developed based on Python, you will might have a doubt like whether I should learn the Python. No, not required. Without any prior coding skills, you can work with the Ansible, right? So this is the benefit of the Ansible here, right? So these programs are used to put the system in a specific desired state. So what is this specific desired state? Take a small example. You want to find out like whether you're looking for some file, and if a file is exist, you want to see whether the data is there. And if the data is there, you want to see whether it has some certain permissions or not. Okay. So you have written a playbook. Okay. You have written a playbook and you want to, so the playbook is written on the control node. See here, this is my control node here. Okay. And this is my manage node. Okay, so as you're seeing that this is my control node and this is my manage node, it is connected in the network and all the connectivity has been established, everything is fine, and you have written a playbook to check that. I want to see, I have written a playbook saying that first I need to check whether the file is existing or not. And if the file is existing, I need to see the content is existing or not. If a content is existing, whether the file has a certain permissions or not. This is what exactly the purpose of the playbook. So you will use some playbook commands and you will try to run this playbook from the module, I mean, from the control node, and the playbook is pushed to the manage node here, right? So as the playbook is been pushed from the control node to play manage node, what it will do is first it will try to check. Okay, what it will check whether the file is existent. Assume that. So take an example. If a file is not exist, it is not available. Okay, if it is not available, so what it will do? It creates it. It creates it. It creates. I mean, it creates. Right. So after it creates, now we don't have a data, right? It also adds the data. After creating, add the data. Add the data and set permissions. This is what exactly it is going to do. For example, you will say that if a file is available, then what it will do? File is available. If a file is available, then it do nothing. If a file is available, if content is same, if your permissions are set, it do nothing. Remember, it do nothing. It do nothing. This is what exactly. That means what it will see is it will check the machine state. Okay, whatever the task it has to perform, it will see the desired state of that particular task. If the desired state is available, it do nothing. If a desired state is not available, it will try to make the changes. This is what exactly. And this kind of things are, it has some certain terminology. We call it as an idempotent. We call it as idempotent, right? So the entire Ansible playbook and modules and tasks and the arguments, whatever you're going to use it, that are being designed in idempotent. So what is the benefit of idempotent? So this idempotent feature will allow you to run the playbook for multiple times on a machine. Okay, because it do nothing to your machine, right? So it is safe, it is secure. Okay, so this is the benefit here. This is a benefit here. Take an example, you're running a playbook to create an HTTP package installation, enabling a service and configuring some, configurations and testing the web page. right? If it is already there, it do nothing. If it is not there, yes, definitely it make the changes. It will try to implement the entire playbook there. This is what exactly it is going to work. Okay, so I hope you understood like what is a desired state of the it will try to put the put the system in a desired state, and any module that are pushed and removed from the when the Ansible finishes. Take an example. I said that just now the Ansible playbook consists of play, task, and module and task. The modules are being pushed from where? The modules are being pushed from your control node to manage node, and after it completes the task, it will try to remove the modules. There will not be any proof that using Ansible you have configured the entire configuration, nothing like that. Okay, so this is what, and you can start using Ansible almost immediately because no special agent needed to be approved for the use, then deploying. So this is what exactly right we discussed yesterday. So this is what, and it is secure to communicate because SSH is a, it's a very good service. We are using it from very long time, and SSH has been developed a lot. you know Nowadays, maybe I am maybe you are aware of, not, I don't know, whatever the SSH we are using, what is the encryption method that is being used, what is the encryption algorithm that is being used by SSH, that. See, we are using right now, the current is SSH version 2. And when I talk about SSH version 2, it by default support RSA algorithms, and ECDSA is another algorithm it is going to support. Whenever you're connecting to the remote machine, by default, we go with ECDSA only. And it is going to encrypt the data in 256 bytes of encryption it is going to use. 256 bytes of encryption it is going to do. Right? And what is the encryption method of RSA? RSA is going to do 2048 bits of encryption. So you will say that RSA is doing a lengthy encryption, right? Why don't we use RSA? So RSA has some drawbacks. Your data is 1 MB. It has been encrypted in very lengthy encryption. Because it is performing very lengthy encryption, the data delivery is slow, the communication is very slow, network overheads will happen because the small data has been encrypted in very lengthy, long, and very huge data. That will be a problem, right? So that's the reason what we need to do. You should be careful. You should be careful here. You should be careful. That's the reason it is always recommended to use ECDSA. I mean, by default we use ECDSA. There is nothing like okay, so you will ask me, ECDSA is a 256 bytes only. Do you think that it is very, I mean, it is very strong, or, it is very secure? Yes, 100%. It's a very old encryption, but still it is very good. Compared to RSA, the encryption is very high here, right? So this is what exactly we are going to use. And as I told you, right, we are going to use SSH passwordless authentication, or we'll call it as a key based authentication. We have a public key, right? Public key based authentication. This is what we're going to use it. Okay, so this is all about like how we are going to use SSH here. And WinRM, definitely I'll give you one example by communicating with the Windows machine also. Then Ansible has a number of important strengths here. The first thing is cross-platform support. So basically, right now Ansible is there for Linux and Windows, right? So you can download the package for Linux, you can download the package for Windows, right? But most of the time, what I see in real-time projects, your Linux machine will be a control node, right? So this is what exactly, and you can deploy and you can manage whatever the environment that it is available on your your data center, on your IT infrastructure. You can manage your network devices, you can work with physical, virtual, cloud, and container environments. Anywhere you can work it. So there is no such limitation saying that, oh, this environment is not suitable, there is no modules for this application, there is no module for that application. There is nothing like that. Whatever the standard tools and softwares that has been used in the real environment, all this are supported by the Ansible, Okay. Now the next thing is human readable. Already we discussed the playbooks written in YAML, and it is easy to read and help to understand. And next is a perfect description of the application. So every change can be made by the Ansible playbook, and every aspect of your application environment can be described and documented. So I can say that described and documentation is the big problem of the real-time projects. You're getting it? So why it is big problem, like take an example. I am only working in some project, and take an example. I got some ticket, I got some task. Some of my clients send me some task for some implementation, right? I have started doing the implementation, and it took some time, 1 or 2 months, to deploy everything. And basically what I did is, I have done, uh, impossible to a possible things I have did. Basically, if some other person have done it, they used to leave that implementation, because there are a lot of challenges we have faced. And so they might leave it. But what I did, I have taken it as again challenge. And because I want to prove myself, what I just made it happen, right? So very fine. Where we got very good people have appreciated us, and everything went on fine. But the management, what they asked me, like as a senior guy, he just called me and he messaged me and said that whatever the implementation you have done it, can you document it for us, right? So what I feel is, when they ask me for documentation, I'll say yes, but I never provide them the documentation. And finally, when I get a new offers, like new companies with new good salaries, I'll leave the project. Before leaving also, they ask us for documentation. But what I do is, I don't give them full documentation. I'll give them 50-50 documentations here and there. I'll just try to give the documentation, and I'll leave the company. I'll go with some other company. So in my place, someone will come, and just he want to understand the things, and he want some problems comes, and he has to understand all the steps and all the configuration things to troubleshoot. So when he see for a document, he don't find a proper document. Like what he need to do? There's a lot of time wastage, again, like whatever, like things I have done from the scratch, he have to start from again zero, and he have to perform everything. He has to start from the zero, and he has to perform everything. This is what exactly it has to be done, right? So this is the things here. Okay, so that's the reason. But when it comes to Ansible, whatever the task you're going to perform, you have to write a playbook. And when you are writing a playbook, you have to describe each and every step of the playbook. And this will help a lot for administrator, or a person who is working, who is new to that environment, easy to understand the things. This is going to solve the very big problem of the real time. Okay, so this is what, and easy managing the version control. Very simple. This version control concept is especially for development side, right? If you are just a developer, right, you are trying to write some code to develop in a software or application. Today you have written some code and you have sent it, and it is that the code has been tested. It has been assembled and tested, and it has some problem. They revert back the code. Again, you're going to modify. You'll give a new version to it, and write a description, detailed description, what problems has been fixed from the previous version to the new version. And then the code again sent to the code will be assembled and again tested. If it is good, they try to use it. This is what exactly happened. So this all version control concepts can be controlled by the Ansible. Support dynamic inventories. So as we discussed yesterday, inventories are two types. One is static inventory, another one is dynamic inventory. So when I'm talking about static inventory, it's just a static file where you put the host names and IP addresses. But dynamic inventory is totally different. We never define any file. Okay, it dynamically takes the machine's information. So where the dynamic inventories are used, basically dynamic inventories are used for cloud. For what reason it is used for cloud, right? So especially when it go to the cloud environment, As you power on the machine, you will get a new public, I mean, it's a new public IP you are going to get. With that public IP only, the host names are represented. SRO, right? So that means every time when you power off and machine the cloud instance, you know, so every time you will going to get the new IPs and you need to track that machines, right? So if you want to track, I don't have information because every time the machine IP is changing. So we are going to use a dynamic inventories to track such kind of machines and to communicate, right? And this is what exactly, and orchestrating that integrates an easily with other systems, like you can integrate with HPSA, Puppet, Jenkins, Red Hat Satellite, and other tools can be integrated with Ansible. Okay, and you can make it more productivity. Okay, so this is all about an Ansible language for DevOps. So this is the language for DevOps. So from development to outsource is nothing but it's equal to the production. So this is the core areas where the Ansible is used. So because of this reason, people are using Ansible, single tool that gives you that works in all the areas of your infrastructure. Okay, so this is all about and Ansible concepts and architecture. So as we discussed yesterday, like inside the Ansible architecture, we are going to see two missions. One will be a control node, the another one will be a managed node, right? So what is control node? Control node is a mission where the Ansible is installed. Very simple. Okay, and most of the time people have a doubt. What should be my control node? Okay, should I go with a dedicated mission? Yes, or what exactly? Okay, so basically when I'm just talking about the control node here, it can be any mission. It can be any machine in your environment. So when I'm saying that it can be any machine in your environment, very simple here, right? You might be seeing a core production server. You'll ask me like, can I install Ansible there? 100%. You can install it, right? Now you'll ask me, will there will be any load on it? What is it? I mean, there is nothing load there. What you will do on a control node? Tell me. Okay, so very simple here on the control node, you will log in as a normal user, right? You will just try to write the playbook and you will try to push it to the remote machine. So you're just going to push it. So the entire task, whatever the performance it is been has to be done, that has to be done only on the managed node, right? You are just pushing it. Okay, so this is very important thing here. Okay, so many people don't understand this, so they feel that a control node should be something called, it should be a dedicated machine. No, nothing like that. It can be any machine. It can be a personal laptop also, which running with Linux or Windows. You're getting my point. Okay, so these are all important things that you need to know, right? So it can be any machine, production, non-production. It might be your laptop, it might be a lab desktop, it might be your virtual machine, it might be a cloud machine, it might be a container. Anything will work there. There is no restriction. Now, when I talk about a managed node, what is managed node? Managed node is a machine or the list of hosts that we defined in inventory that are, recognized as a managed node. Why? Because if I don't define the list of hosts in an inventory, you will never recognize that machine as a managed node. And as we discussed yesterday, what is inventory? So inventory is equal to etc host file. Inventory is equal to slash etc slash host file. This is what exactly. Inventory is equal to slash etc slash host file. This is what exactly we have. Okay. So what is the use of etc host file? You all know very well. You're going to define the host name that you want to communicate with the host name. At the same time, when we go for an inventory. Inventory is also something like this. I'll just try to show you the inventory here so that it will be easy for you to understand. So inventory looks like this. Yes, sure. So let me get to the project directory. So do you see there is a file with the name called inventory? This is my inventory here. So these are the machines I'm going to communicate. I have gathered the machine IP addresses or host names or a fully qualified domain names, and I just maintain here. You're getting my point. And whenever you're writing a playbook, right? So you will try to define the host name that is there inside the inventory. And as you define the host name inside the inventory, it will go and hit up, right? By verifying the inventory. This is what, if the host name is not defined inside the inventory and you have defined the host name inside the playbook, assume that. Okay, you can see that I'm having a host name here called yumnode1.lab.com. But we have defined the host name in the playbook, but the same host name, it is not present in the inventory. Okay, will it works? No, it doesn't work. This is very important thing that you need to understand. Clear? So this is all about how it is going to work. Okay, so make sure that all your host names, I mean, is there available? It's updated in the inventory. If not there, you need to just update it. This is something called a static inventory. So let me get in the document. And then the manage host is listed in the inventory, in an inventory which is also organized the those systems into a group and easier collective management. So you can put all the host into a form of group so that it will be easy for you to perform the operation, right? So inventories can be defined in static and dynamic. So we will discuss detailedly about it later. Instead of writing a complex script, Ansible user create a high level place to ensure that host or a group of hosts in a particular state. A play perform in a series of tasks in a host on the host in order to specify the play. So this is what exactly. I'll not go much with the things. I'll not read much. This is all the theory we have already discussed. It's an YAML format, right? So this is what exactly. And the text file that contains one or more play are called playbook. One or more play is called playbook, remember? And each task runs the modules. Module is nothing but it's a small code written in Python, or if it is Windows, it is a PowerShell, remember? And of course, other languages also it is being supported by the Ansible. Like you have a JSON, right? It will support, right? Even it supports, the other languages like what we say apart from JSON, it will support. What is that? Jinja to templating, it will support. Okay, it supports, YAML also can be supported. So this is what exactly. And every module will have something called arguments, and each module is essential toolkit. This is all the things we call. And we also have something called API calls. I told you we have discussed this lately. And when I'm talking about the modules, as you know that Ansible provides you a very good lengthy list of modules here. So you want to see how many modules we have. This is a command gives you the list of modules. There are 3,387 modules that is there on your machine. Getting my point? 3,387 modules we are having here. Okay, so, and I also told you, like when I talk about the modules, when I just run this particular command, it will give you the path of the module here. You can just observe as I get into it. There is a directory with the name called modules. And as I go into the modules, there is a categories of modules. Can you see this? You have a cloud clusters, inventories, monitoring tool, network, package, packaging. Right, let me go to the packaging here. I'll just try to run. This is what exactly. You can go with the OS. You'll see this is a OS related packaging. Can you see this? It supports most of the operating systems here. You can just see if it is Ubuntu, you go for APT. If it is a Linux, you can use yum, you can use RPM, or you can use DNF, right? If it is AIX, you need to use install P. Can you see this? Okay, so this is what. So there are so many other things also we have that you need to go for. So if you want to go for Red Hat subscription, you can go with the subscription here. If it is a Solaris, this is the things like a PKG. This is a modules that is use PKG only. I think packaging. This is usually this. This is what it's going to work, right? So this is all RHN subscription related modules we can say. Okay, so this is all. And when you're using, okay, so already we have discussed that all the modules are designed, task and play and playbooks are designed in idempotent. This means that you can safely run the playbook on same system, same host multiple times. Okay, when your system are in a correct state, the playbook makes no changes when you run it. And this means that you should able to run a playbook on the same host multiple times safely. When your systems are in a correct state, the playbook should make no changes when you run it. And there are a handful of modules you can use to run arbitrary commands. However, you must use those modules with care to ensure that they run in an idempotent way. This is what. And when I talk about plugins, plugins are extension to your modules, we can say. And Ansible architecture is agentless. We discussed very well. And Ansible Tower is an enterprise level framework to may help you and control and secure and manage your Ansible automation at scale. This is what exactly. And you know that Ansible Tower is especially an web-based UI, and it has a REST API full of APIs to scale your environment. So this is what exactly. So we are discussing something about this diagram just now. Okay. And you know that Ansible, like when we talk about the complexity kills the productivity, you know, when I talk about complexity kills the productivity. When I talk, whenever you see a real projects, right? Most of the times, you know, whatever the design, whatever the implementation we do, we make it very simple, right? Because after me, someone joins, okay, he should able to understand the environment in very detailedly. Okay, so that's the reason it should be designed in very simple way, right? And optimized for the read. Okay, readability. As you understand that Ansible automation language is a declarative text-based file, so that will help you out in understanding the entire playbook in human readable. And think declaratively. Ansible is a desired state engine. So this is very important thing. Ansible is desired state engine because the Ansible as playbooks, whatever you're going to run, it is like idempotent, right? That's the meaning here. Okay. Idempotent means what? If the configuration is exists, it do nothing. If it is not there, it will try to implement it. Okay. So this is all about. So this image will give you the process here. And when we talk about use case here, configuration management you can do. You can do an application deployment, right? You can deploy any application. Then provisioning is very important. So many times people have a doubt whether Ansible works at the bare hardware level. Can I connect to the ID rack to install OS? Or can I connect to the VMware ES6 hypervisor to create virtual machines or to manage that entire environment? Yes. Using Ansible, you can provide a bare metal. You can access your bare metal hardware. Is this clear? This is what exactly. And you can use the remote installations like network installations using PXE or any other type of remote installations. You can do it. And it supports CI/CD. That is called CI/CD is nothing but continuous integration and continuous deliveries. So it's specially used when it go for DevOps side and security compliances and orchestration. This is all exactly the Ansible is going to support. Okay. And we have some useful links here where you can just click on those links to understand what is, I mean, how the Ansible is going to work, all those things. So this is good. And you know, even I'm going to share this document to you. After every chapter, you will find two informations here. One will be the small quiz will be there. You can just answer it. And second thing is like it is going to provide us a guided exercise, right? Okay, the guided exercise is nothing but the scenarios that we are going to use it. Okay, so this is what exactly. So I'll just try to read these questions. So which of the following term best describes the Ansible architecture? What exactly is the answer? Is it agentless, server and client, client and server, or it is agent driven or self driven? Yes,
Agentless.
yes,
Agentless.
it is agentless. Yes, it is agentless. And which network protocol does Ansible use by default to communicate with manage the node? So what is a communication protocol, network protocol? Is it going to use HTTP or SNMP or SSH or SMTP, SNMPS?
SSH.
Yes, SSH it is going to use. And which of the following file defines the action that Ansible platform performs on managed host?
Playbook.
Yes, playbook it is. And what syntax is used to define the Ansible playbook? It is nothing but YAML. Okay, this is what exactly it's going to be. And actually, the next session is like we have to implement the Ansible lab environment. We need to go with the installation. So what I do is, what I recommend is before, I mean, today, not today, tomorrow we are going to see the lab, not today. So for the lab, you need to do one thing, create two missions, create two VMs. Okay. And install Red Hat 8.5. You will say that, can I install 9? Yes, you can install, that's not a problem. Okay. It's all up to you. You should go to the access.redhat.com. You should subscribe yourself and then try to download the Red Hat Linux operating system. Right. So after installing it, then the first thing is make sure SSH passwordless authentication need to be done from server A to server B. This is what you need to do. Then later configure a local yum repository. Local yum repo. Then after configuring yum repo, then the third one is we will see the installation. Okay, and we will make sure that you are able to communicate to the managed node without any issues, right? These are very important things. Any doubts, let me know.
So the passwordless will be for which user?
By default, there will be some, we will try to create some default users there. Sometimes we will try to create a user with the name called DevOps like this, or we will try to create a user with the name called Ansible. If not, you might use your own name also because you are a member of that domain, right? You are anyhow, you are having a network user. Using that also you can work.
Okay.
Right? So this is all about. So for today, what I'll do is I'll stop here, right? So tomorrow we will go with the lab setup here. I'll try to show you in front of you. I'll try to create the machines and I will implement Ansible and I'll configure the manage node also. Is that clear? Okay. So this is all about how it is going to work. This is all about the today's session. So don't get bored like I'm reading a lot of text. Only for the first chapter we will go with because we need to just follow some content. So from tomorrow onwards, we don't read this much data. We will just see all the practical things much. Okay. So this is all about. So if you have any doubts, any questions, you can ask me. Otherwise, we'll stop here. So Vijay, do you have any doubts? Amol, so you have
No,
any doubts?
nothing as of now. So
No,
we'll create two machines for
yeah, two
tomorrow.
machines and you need to work on it and make sure that you have enough RAM. That's a very important thing.
Hmm.
You should have minimum 8 GB RAM. Then only it will be easy for you to work with the machines remotely. I mean, you can create a virtual machines and you can work on it, right? That's the reason you need enough RAM.
Right.
So this is one important thing that you need to keep it in mind. So that's it. See you tomorrow, same time. Bye.
Bye.
Okay, thank you.